Example 2. An experiment consists of rolling two fair dice and adding the dots on the two sides facing up. Describe the sample space, and assuming each simple event is as likely as any other, find the probability of the sum of the dots indicated. All right, so what's going on here? You've got two standard die. Okay, so if you take a dice, the usual dice is a six-sided cube, and it's got dots on it, and each side has the dots summing up to 1, 2, 3, 4, 5, or 6. Okay, so you've got a pair of these dice, and they are fair dice, meaning they are the standard dice, not the any kind of wonky dice where one, it might have a whole bunch of sides, and one face might have a greater area than another face, and so on. So there's no wonky dice, just plain old standard dice that you always see. Okay, so you've got a pair of dice in your hand, and you're going to shake them up and you're going to roll them, and we are going to notate what the result is, and we're also interested in summing the dots on the faces that are on the sides that face up. Okay, so the first thing we need to do, it says to describe the sample space, and so sample space is all the possible outcomes. So what I have here is kind of like a little chart. Again, there are going to be two dice, so we're going to kind of pretend that we roll the pair of dice and record what we might see if we actually did this. Now remember, if you had two dice, suppose that one was blue and that one was orange. So you could keep track of what shows up on the blue die and what shows up on the orange die. Okay, so yeah, that's going to help a lot. Okay, because you need to be able to tell, what shows up on one particular die and what shows up on the other. Okay, so I'm going to call this, we'll say this is die number 1, and maybe this is our blue die if it were that color, and then we'll say over here this is die number 2. We'll suppose that, or pretend that this is orange. Okay, so just imagine shaking them up, rolling the pair of die, and we're going to write down what we see, what shows up on the top face. Okay, all right, so the way you want to read this, okay, so for this particular position, okay, we'd be looking at, what goes in this spot. On die number 1, a 1 is rolled, and on die number 2, a 1 is also rolled. Okay, so I would record this as 1, 1. Okay, meaning a 1 first shows up on the blue die, and then a 1 also shows up on the orange die. Okay, the way I'm doing this is that the left number indicates the blue die, and then the right number indicates the orange die. Okay, so if we filled this in, if we went this way, and then in this position, this is saying that you rolled a 1 on the blue die and then a 2 on the orange die. Okay, here would be a 1 on the blue die and then a 3 on the orange die. Okay, and you could keep doing this. If I went this way, that means I would roll a 2 on the blue die and then a 1 on the orange die. Okay, here I would roll a 2 and a 2 on both. Okay, I'll do one more. Okay, so then here, this is indicating in this position that we rolled a 3 on the blue die and then a 1 on the orange die. Okay, so we could fill this in and we would get our sample space. We would get all the possible outcomes. Okay, I'm going to pause the video. I am going to continue to fill in this chart, and then I'll start the video up again after I've filled out this chart completely. All right, I'm back. I've got the chart completely filled with the potential outcomes. Okay, so again, what I need you to notice is I'm gonna show you a couple of these. So say I look at this outcome versus this outcome. Okay, these two outputs that I've got underlined in red are not considered the same. This one means that you would have rolled a 4 on the blue dice and a 2 on the orange dice, whereas this particular output means you would have rolled a 2 on the blue dice and then a 4 on the orange one. Okay, so order does matter here because we are keeping track of how many dots show up on each individual die here. Okay. All right, so here are all my outcomes of what you can roll, rolling that pair of dice and see what you would see on both of the dice. Okay. All right, so what you should notice, okay, this is our sample space. There are 36 possible outcomes. If you count each one of these guys up, okay, count them all up, there are 36 possible outcomes. So I'm going to write that right here, 36 possible outcomes. All right, so now that we know that information, we're going to go to the bottom here and start working on probability, okay? So if we go back to the directions, it says, we describe the sample space and assuming each simple event is as likely as any other, find the probability of the sum of the dots indicated. Okay, so that's what this stuff at the bottom is referring to. Okay, again, when I just read through the directions, it reminded us that each of the 36 outcomes is equally likely. So if I take, the pair of dice, the dice are fair, you roll them, any of the 36 outcomes, one is just as likely as another. Okay. All right, so let's look at part A. We're trying to figure out the probability that you take the pair of dice, you roll them, and you end up with a sum of 8 on the dice. Okay, sum means add. Okay, so it really helps you to see the sample space. So that's why we did this. Okay, so because we're dealing with equally likely outcomes here, we can use our probability principle, which tells us that you're going to have a fraction and the bottom is going to be the total number of possible outcomes, which we know is 36. So the bottom here is going to be 36. The top number is going to be how many of these outcomes meet our criteria. So how many of these outcomes sum to 8? Okay, so I'll put this in red. Okay, so let's go through these different pairings here and see what adds to 8. Let's see. I see one right here. Okay, so 6 and 2, those add to 8. 5 and 3, 4 and 4, 3 and 5, 2 and 6. Okay, so you notice a diagonal pattern here. Across the diagonals, you see the pairings adding to a certain number. Okay, so across this diagonal that I have underlined in red, those guys add up to 8 if you add the dots on each die. Okay, so there are 1, 2, 3, 4, 5 outcomes that meet this criteria. So the top number is going to be 5. So our probability, the answer is going to be 5 out of 36. Okay, leave it as a fraction. You could look at the decimal, which is fine. I mean, I'll go look at that. I do prefer fractions. If we did 5 over 36, you would get this decimal. So you could just write this as 0.138 and put a bar over the 8 saying that that indicates that the 8 keeps repeating. So that would be fine. So you could write this as 0.138 with the 8 repeating. Okay. So you can tell that this from the decimal version. Okay, yes, I obtained a number between 0 and 1, so that's good for probability. You can also tell that this number 0.138, it is closer to 0 than it is to 1. And so this is not very likely to happen when you're rolling a pair of dice. Okay. All right, let's take a look at B. So now we're looking for sums that are greater than 5. Okay, so English comes into play here. What does greater than 5 mean? So this means that the sum needs to be 6, 7, 8, 9, 10, or higher. Okay, the sum cannot be 5 itself. The sum has to be bigger than 5. Okay. All right, so apply your basic probability principle. The denominator is still going to be 36 here. There's 36 outcomes. We just need to figure out how many of these outcomes fit the bill. How many sums are bigger than 5? Okay. All right, let's see, I'll highlight this in yellow. Okay, that way we can see. Okay. All right, so let's go back to our sample space here. Again, we know if we go diagonally, the pairs should add up to the same number. So I'm starting to look around and I see right here, 5 plus 1 is 6. Okay, so that's bigger than 5. If I go up 1, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5. So I found the 5 diagonal, but I don't want that because I need the sum to be bigger than 5. So I need to start right here. This has a sum of 6, sum of 6, sum of 6, sum of 6. Okay, so everything this way below this yellow diagonal line should work. Okay, so now I'm going to highlight the guys that have a sum of 7, and then a sum of 8, sum of 9, sum of 10, sum of 11, and then the highest sum you can get is 12. Okay, so we need to count up how many of these yellow outcomes we see. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, so 26 out of the 36 outcomes result in a sum being greater than 5. Okay, and I'll go ahead and correct this little comment I made. Okay, we're looking for sums starting at 6 and going up to 12 because 12 is the highest sum you can get there. Okay, all right, so here's your probability. If you want to, you can reduce it. It is not a requirement, but you could reduce this fraction to be, both of these numbers are divisible by 2, so this could be 13 over 18. Okay, and again, if you went to your calculator just to check out what this looks like, you could put in 28 divided by 36, or you could put in the reduced form, okay, and you're going to get this decimal, okay, 0.72 with the 2 repeating. Okay, all right, so that's your probability. Okay, again, the decimal version is closer to 1 than it is to 0, so it's more likely to occur than a sum of 8. Okay, which makes sense. Okay, you obviously had a lot more outcomes falling into this category. Okay, another way you can think of this, remember, any decimal can be converted to a percentage. Okay, so this is approximately 72.2%. Okay, so the probability of rolling a sum greater than 5, you have a 72.2% chance of rolling a sum greater than a 5 when you roll a pair of dice. So you can think of it that way. Okay. All right, let's try a couple more of these. In part C, careful here. We want the sum to not be 2, 4, or 6. Okay, we want the sum to not be 2, 4, or 6. So anything is going to work except for those sums. Okay, so I am going to try to put this in a different color. Okay, so let's find the sums of 2, 4, and 6, and then we'll exclude those. Okay, so let's see. This is a sum of 2. Okay, this diagonal is a sum of 3. Here's a sum of 4. And then we have the sum of 6. Okay, so let's do it this way. Okay, how many did we highlight blue? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 of them actually are 2, 4, or 6. Okay, so what we're going to have to do here is, I know there's 36 outcomes total, and 9 of them have sums that are 2, 4, or 6. So I'm actually going to subtract out here. That's one way of doing this. So if I do 36 minus 9, that's going to give me 27. So that means that 27 of the sums are not 2, 4, or 6. So the probability here is going to be the desired outcomes. There's 27 of those, and then the bottom number needs to be 36. Okay, so let me keep the color coding correct here. So out of 36 possible outcomes, 27 of them fit the bill. Okay, so here is our answer, 27 out of 36 for this particular one. Okay, again, you could reduce the fraction only if you wanted to. Both of these numbers are divisible by 9. 27 divided by 9 is 3. And then 36 divided by 9 is 4. Okay, that's 0.75. Okay, so you can write the probability like that as well. Okay, 27 over 36 or 3/4 or 0.75 exactly. All of those are the same. Okay, so what this is saying is if you roll a pair of dice, you have a 75% chance of rolling a sum that's not a 2, a 4, or a 6. Okay, all right, last one. This may be the tricky one. The sum needs to be divisible by both 2 and 3. Okay, so we're going to have to go figure out from the sample space who meets this criteria. And I'm going to put this one in purple. Okay, the sum has to be divisible by both 2 and 3. So the sum, 2 has to go into the sum and 3 has to go into the sum. Okay, so like for example, right here, 1, 1, the sum is 2. 2 divided by 2 is 1. That works. But if you did 2, which is the sum, divided by 3, that doesn't work. Okay. So actually, instead of going to each one of these and trying to test them out to see if they work, this is what I'm going to do. Okay. What are our possible sums? We know that if we add the dots, we're going to get 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. Those are our possibilities, okay? Let's just look at this and figure out which of these numbers are divisible by both 2 and 3, okay? 2 doesn't work because you can't do 2 divided by 3, okay? 3 divided by 3 works. That's 1, but 3 is not divisible by 2. 3 divided by 2 is going to give you 1.5. It doesn't divide evenly, okay? It doesn't work. All right, then you got 4 divided by 2, that's 2, that's good. But 4 divided by 3 is bad, okay? 5 divided by 2 gives you a decimal, okay? 6 divided by 2 gives you 3. 6 divided by 3 gives you 2, okay? So that's our first number that's divisible by both of those, okay? 7 divided by 2 gives you a decimal. 8 divided by 2 works, but 8 divided by 3 gives you a decimal. 9 divided by 2 gives you a decimal. 10 divided by 2 is 5, which is great, but 10 divided by 3 gives you a decimal. 11 divided by 2 gives you a decimal. And then 12 divided by 2 is 6. 12 divided by 3 is 4. 12 is the other sum that is divisible by both 2 and 3. Okay, so what this is saying is we need the sum. The sum has to be 6 or 12. Okay, so like I said, I'm going to put this in purple. Okay, let's go figure out which pairings do that. Okay, so I'm looking through here and I need sums that are 6 or 12. All right, well, here's 12. Okay, that can only happen one way. 6 and 6 is 12. And then if I'm looking for the guys that add up to 6, it's going to be this diagonal. Ooh, that's bad. It kind of blocked out what I was doing here. Okay, all right, I'll circle it in purple. Okay, so we've got this combination. Okay, so here's another 4 on the blue die, 2 on the orange. That's going to add to 6. This is going to add to 6. This is going to add to 6. This is going to add to 6. Okay, so there we go. All right, so out of the purple ones, if we count up how many results that is, 1, 2, 3, 4, 5, and 6. Okay, so 6 of the possible outcomes fit this criteria out of 36 total. Okay, so there's your probability. This reduces to 1/6. Okay, if you look at your calculator, 1/6 is this decimal, so 0.16 repeating. Okay, so that's this decimal. Okay, put the bar over just the 6, okay, because only the 6 is repeating, not the 1/6, okay? All right, so that is your answer, okay? If we compare the decimals, just for kicks here, out of the 4 possibilities here, we've got 0.138, 0.72, 0.75, and 0.16. The most likely thing to happen would be to roll a pair of dice and get a sum not equal to 2, 4, or 6. That was the highest probability we got. And the smallest probability we got came from part A. 0.138 is smaller than all the other numbers. So the sum of 8 was the least likely thing to occur.